All right, welcome back to my channel. If you are just joining this channel, this is the second episode on this particular subtopic, tangential curves. So once we have another example on these tangential curves, if you are watching this for the very first time, please subscribe to this channel. That's how you encourage us to do more. And place your comments if there's any question. Place your comments. I will respond in time. So now let's look at another example on tangential curves. We've been able to do this. I believe you enjoyed the way we did this. We were able to construct this using these first two principles. Now the third principle will be applied on the next example. When two arcs are supporting each other, we have to subtract their radii. Let's look at the third example. Okay, this is it. Okay, if you look at this now, critically you realize that there are two circles involved here. There are two center lines here. There is center P and there is center O. Center O is for the smaller circle, center P is for the bigger circle. Okay, now there is an arc here, arc of radius 25 millimeters, which is joined to the smaller circle and the bigger circle at the upper level here. And we have another arc, a very wide arc, which has a radius of 90 millimeters and is joined also to the two circles at the lower part. The distance between the centers for the two circles is given as 70 millimeters. Okay, so we are going to the drawing board now. Let's try and see what we can achieve with that. All right, so please follow me as we move to the drawing board. All right, this is another question on the tangency that we want to work on. All right, just like the one we did before. So this one obeys the last two principles. The first one which says the second principle which says that when two arcs when two arcs are opposing each other, you add their radii. Then the third principle which says when two arcs are supporting each other, you subtract their radii. So we can find this in this particular task before us. Now look at this this connection here. If you look at it very well, you realize that we have two circles here. This is a circle and this is another circle if produced. This is a circle, this is another circle, and this is an arc connecting the two circles together. This arc has two ends. It's connecting to this at one end here, connecting to this bigger circle at the other end. Now there's another arc here joining the two circles externally this way. This arc also has two ends. One end is connected to the smaller circle and the other end is connected to the bigger circle. All right, so where is our principle coming in? The first principle that says, now let's look at the arcs. Let's look at this first arc here. This arc, if it is produced further, can you see the arc? If we produce this arc further like this, which means it's going to go this way, but the circle is going this way. Can you see? The arc, if produced further, is going this way, but the circle is going this way, which means they are going different direction. They are opposing each other. So in this case, we add their radii. Okay. Now let's look at the other end of the arc where it is connecting to the smaller circle. So let's produce the other end as well. So this is the other end coming this way. So if we produce it, it's going to go this way. But the circle which is connected to is actually going this way. So which means at this point also, they are also opposing each other. So what do we do here? We we add their radii, because the arc and the circle are opposing each other. So let's deal with this one first before we now move to the other one. So to start with, the first thing you do is to draw your line. So in this case, we have center PQ for the two circles, center P for the bigger circle, center O is O actually, center O for the smaller circle. So I would like to draw the two centers first. I'll start by drawing the two centers. This is my horizontal center line. When you are drawing center line, make sure it is always a center line. Okay. Now, at any point here, I'm going to draw a vertical center line, which will give me my point P here. Okay. So this is my point P. Okay, now from P to O is given as 70 millimeters. So I'm going to measure that from P, 70 millimeters to O. So this will give me, this is my 70 millimeters. So which means this is my point O. So I'm going to label this as point O, and then I will draw the center line at that point as well. So I have the two center lines, so all I am left with is now to draw the two circles. So I will draw the bigger circle. The radius of the bigger circle is given as what? 50 millimeters. So I'm going to set my compass to 50 millimeters. I'll measure my 50 millimeters here, which is equivalent to what? 5 centimeters. Okay, so I will draw this at point P, which is the center of my bigger circle. I'll draw the circle. It's a very big circle, as you can see, but I'm not going to outline it yet. I'm going to make it thin for now. I'm going to make it thin. Now for the smaller circle, the radius of the smaller circle is 25 millimeters. So that is 2.5 centimeters. Yes, here it is, 2.5. So I'll come to center O here and draw the second circle. You can see the two circles are intersecting each other. It's not a problem, okay? Just make sure they are thin circles they are drawing. We can actually erase the inner part later. Now we've been able to draw the two circles. The next thing to do is now to draw the tangential curves connecting the two circles. So we are going to start with this one. We have established that this arc is connecting to this, is opposing the two circles. It's opposing this bigger circle. It's also opposing this smaller circle. Now, at this point now, let's deal with the bigger circle first. So since it is opposing the bigger circle, the rule says we should do what? Add their radii. So what is the radius of the arc? 25 millimeters, right? Then the radius of the circle is what? 50 millimeters. So when you add it together, what do you have? 75 millimeters. So I'm going to set my compass to 75 millimeters. 75 millimeters. Okay, this is 75. Now, since the arc is connecting the bigger circle, so I'm going to use the radius of the bigger circle as my center, and then I will draw an arc here. Okay. Now, let's look at the situation with the smaller circle, the same situation, opposing the smaller circle as well. So we are going to add the two radii also. What is the radius of the arc? The radius of the arc is still 25. Radius of the circle, which is connecting, is what? 25 as well. So when you add the two together, it gives you what? 50 millimeters. So I'll set my compass to 50 millimeters. Make sure you measure accurately. Take your time. Right, so this is my 50. So where's my center? Because this arc is connected to the smaller circle, so I'm going to use the smaller circle as my center and draw that arc to intersect the previous one at point what? Point Q. So the point where the two arcs meet here is my point Q. So this point is my point Q. This is my point Q. Now I want to draw the arc. Now to draw the curve, to draw the arc connecting them, now you are going to draw a straight line. There's no need to guess here, because we need to know the exact point where the arc is touching the two circles. So you are going to draw a straight line from your point Q to the center of the two circles. So thin straight line to the center of circle P, then thin straight line to the center O as well. So which means the arc is touching the circle at this point, this bigger circle at this point, and is touching the smaller circle at this point. Now let's test that. So I'll put my compass, set my compass, put my compass at point Q here, and extend to the point here where it is meant to touch the bigger circle, this particular point. So then I will draw the arc. It's meant to, can you see? Perfect. So this is what we want to achieve here. So I'm going to draw this arc. Don't make mistakes. Don't be too excited. Make mistakes. Don't make mistakes. Okay, this is good. This is good. I love the result here. So this is it. Once your calculation is correct, you have your tangential curve drawn perfectly. So I'm done with the connection at the top here. Now I want to move down to the lower part. Now this is another arc. The radius of this arc is 90 millimeters and is connected to the two circles. Now let's see if it is supporting the circles or it is opposing them, as like its brother, the previous one. Now let's look at the relationship, the situation at this point where the arc is joining the bigger circle. Now look at this curve, this arc. Can you see? This is the curve, the direction of, if this curve is produced, what's the direction? It's moving this way. And you can see also the circle is also moving this way. So which means the curve is moving in the same direction with the circle at this point. So this curve, this arc is supporting this particular circle at this point. Let's look at it. Let's look at what it's doing to this other circle. So if we produce this arc also at the other end, it's also going this way. And the circle also is going the same way. Can you see? So which means the arc is also supporting the smaller circle. So what does the rule say about that? The rule says that when the two arcs are supporting each other, then we should do what? Subtract their radii. So let's follow the rule. Now let's deal with this point first. The two arcs are supporting each other. So what is the radius of the arc? The radius of the arc here is 90. Then what is the radius of the circle is connecting with is what? 50 millimeters. So we are to subtract the radius of the circle from the radius of the arc this time around. So that will be 90 minus 50. That will give us 40 millimeters. So at this point, we are going to have 40 millimeters. So I've set my compass to 40 millimeters. I'm going to set my compass to 40 millimeters. Set your compass to 40 millimeters, which is equivalent to what? 4 centimeters. Okay, here's it. 4 centimeters, perfect. Now, where do we put our compass? What's our center? Because the arc is connecting to the bigger circle, so we are going to use the radius of the bigger circle here. So I'll put my compass the center of the bigger circle, and I will draw the arc here. Can you see from the question? See the location of the arc. This is where we are supposed to draw this arc from. This is the point. So this point R. So which means this is the direction where you are to draw your arc. Don't go and draw your arc here. The question is clear that this is where the two arcs meet. Is around here. So this is the side where you are meant to draw your arc. So I put my compass at point P, draw an arc here. Now I'll go further and do the calculation here as well. Now at this point also, we have established that the two arcs are also going in the same direction, which means they are supporting each other. So we are to subtract their radii as well. So what's the radius of this arc? The radius of the arc is still 90 minus the radius of the smaller circle, which is connected to. That will give us 25. So that is that should give us 75, right? 75, no, 65. That should give us 65. That should give us 65. So I'm going to set my compass to 65 millimeters. 65 millimeters. That will be 6.5, right? 6.5. Measure accurately. Take your time here. You don't want to rush it, okay? Any little mistake may not allow you to get your perfect blending. All right, this is my 65. And where do we use as the center? Because the arc is connected to the smaller circle, so I'm going to use the radius of the center of the smaller circle as my radius, as my center, and then draw the arc to intersect the previous one at R. So it's going to intersect this arc at R. This is point R. This is the point where I am to draw the arc from. But yes, how do we now know where exactly is the arc meant to touch the circles? So we are going to draw our straight lines again. So from your point R now, draw your line, straight line from R to pass through P this time around, passing through P to the other side, touching the circumference at one point here. Okay, so this is the point where the arc is meant to touch the circle here. So we can do the same thing to this, or you can leave it that way if you want to. We have gotten one point, so we are going to draw. Let's do the second one also. So I'll draw a straight line to pass through the center of the smaller circle to the other side, touching the circumference at a point here as well. So which means our arc is meant to touch the circle at this point and this circle at this point. So let's try that. Let's see if it works. So our point R is our center now. Put your compass at point R and extend to this point where the arc is meant to touch the bigger circle. Then it's meant to end at this other point. So if your own is not working, then you should try and adjust your work to make it work. Okay. Okay. This is good. So I'm going to draw the arc. You see my work? This is amazing. Hey, okay, the compass is a little slack. That is why you are seeing that double arc. That is not allowed. That is not allowed. Compass is a little slack. I need to tighten it. So I will have to be careful with this compass so that it will not spoil my work. Okay, it's doing that again. Okay, let me leave it like that. Or let me try and retrace this part. Okay, so what I will do now is outline the circle, the part of the circle which will blend perfectly with the arcs. So the circle from here now, I will outline this part of the circle to blend perfectly with the arc. This is good. Outline only the part of the circle which will blend perfectly with the arc. Leave the others thin. Okay, so I will outline the other circle also, the part of the circle which is going to blend perfectly with the arc. I don't want double arc. Okay, this is didn't want to give me double arc. I don't want. So this is it. Alright, so if you have any question, leave a comment. Leave a comment on either the YouTube video or if you are chatting with me in my class, leave a comment on the WhatsApp. Alright, so that's it. The next construction will be an assignment which I'm going to send. So you can try that as well. Try it on your own and see what you can come up with using the principles we have talked about. But I must tell you this, sometimes instead of giving you radius, they may give you as diameter. So use your sense to convert your diameter to radius. Don't go and use for example, if this one is given as diameter and this one is given as radius, so you now want to subtract. You want to subtract diameter from radius. No, you must convert this one to radius. It is radius that you are subtracting, not diameter and radius. So it is radius, not diameter and radius. So take note of that. Watch out for that. That is another way to confuse students on this particular topic. Thank you for watching. Stay blessed. Okay, so if you have been able to construct what the last example, now I'll give this to you to try on your own. We have two circles here of different radii. The first has a diameter of 56 millimeters, the other has a diameter of 32 millimeters, and we have a curve. We have an arc connecting the two circles at the lower level, and then we have a straight line connecting the curves, the circles at the upper level. Okay, so when I just want to give you an hint. This straight line at the upper level should not be drawn directly. It should be constructed. If you want to learn how this is constructed, refer to our previous works. Okay, how to construct an external tangent to two circles of unequal radii. So that's the construction process we are going to use for this straight line. Okay, then use the tangential, the principles of tangency for this lower arc. So let's see what you are able to to get out of this. Thank you for watching this episode. See you next time.